Hi everyone, welcome back to Physics 11. So here I'm going to go over question number 7 from the worksheet 7.7 on thermal energy. So again, you can find these notes in your work energy and power channel under the notes tab at the top. So question number 5 says a 1 gram raindrop traveling at 40 meters per second strikes the surface of 100 gram of water in a glass. How much will the water's temperature change if we assume that all of the raindrop's kinetic energy is transformed into thermal energy and that the raindrop and the glass of water's temperature are initially the same? So the scenario here is basically you have a glass of water maybe sitting out somewhere outside on a table, and you left it long enough that the temperature is the same as the outdoor temperature. So basically the raindrop temperature is going to be the same as the temperature of the water in the glass. So that's one of the assumptions we had to make here. So that means that the Ti, let's just say 2, and let's call the raindrop here our Ti1, are the same. So these are equal. Okay? And the other assumption, the first one says all the raindrops' kinetic energy is transformed into thermal energy. So we're not considering potential energy here, even though we could, because it's falling from a certain height, so it has potential energy, which then transforms into kinetic energy. But I guess to make things a little less complicated, we just say that it only has kinetic energy, and all that kinetic energy is going to get transformed into thermal energy. So here's what we're basically saying. We have some E kinetic that's going to equal a change in thermal energy. So perhaps I should say change in kinetic is going to equal change in thermal. Okay, so in this case, that's what we're going to go with. So we don't know what the initial kinetic energy is, so we're just concerned about the final kinetic energy. So once you rewrite this, we basically only going to have the final kinetic energy. So EK final is going to equal to the change in thermal energy, which thermal energy is going to be the mass. We say this is the raindrop. Thermal energy is going to be the glass. So this is going to be the mass of the glass, which is going to be mass 2 times the C value is going to be the same because this is water, and delta capital T. So that's what we have. Now you can do this in one step, kind of like as one calculation. You can split it in 2 steps. I think on the answer key there's 2 steps. You can calculate your kinetic energy separately and then use that value for energy in your thermal energy calculation to find the temperature change. It's up to you how you want to do it. Either way, you should get the same answer. So we know kinetic energy is just going to be 1/2 m. Let's call the raindrop is going to be m1 and mv final squared. So this is going to equal our m2 c delta t here. Okay. So one thing we need to be careful with is the units, because the mass of the raindrop is 1 gram, the mass of the water in the glass is 100 grams. So we need to be careful with that. Remember, we had to convert it to kilograms. So 1.0 grams is going to be the same as 1.00 times 10 to negative 3 kilograms, because 1 gram is 1,000th of a kilogram, or 1,000 grams in a kilogram. And with the 100 grams, now, let's see, we probably should add a decimal place here. So this is going to be 3 sig figs here. So when we change it to kilograms, we keep the same number of decimals, or sig figs. So this is going to be 0.100 kilograms. So I'm not sure if that's what I did in the answer key before or not, but that's what I'm going to do here. So be careful with the conversion. Okay, so make sure you get the right values. Otherwise, you will get the wrong answer if you don't convert it. It's going to be off by a factor of 1,000 or 100. The next step is, of course, solve for the change in temperature, right? That's what the question says. How much will the water's temperature change? If we assume that, again, we have initial temperature, which is the same. So let's take our equation here and expand it. So we have 1/2 m1 Vf squared equal m2 c. Here we have our T final minus T initial. So the next step is then plug in all the values. And let's see what we can do with the T initial here because it's the same. Actually, we're not going to expand this. We're going to leave it as change because we can't really find the initial temperature. We're just going to know the change in temperature. We don't know what the actual value is. And that's what really, the question doesn't really ask us for the specific value of the water, just says the change. So we're going to leave it as delta T because otherwise we end up with two unknowns which we can't solve for. So we're going to leave it as one unknown as just the delta T. All right, so then we just plug in the values basically, or you can do a little bit of algebra and solve for delta T. So delta T in this case is going to equal 1/2 m1 Vf squared over m2 times the heat capacity. Plug in the numbers, so 0.5 or 1/2 times mass 1, which again, that's the raindrop, which is 1 gram, or 1.00 times 10 to negative 3 kilograms, times the speed, which was in this case 40 meters per second. Don't forget to square it. All of this over the mass 2, which is in this case the mass 2. So let me write here m1, m2 is 100 grams. So that's going to be our mass of the water in the glass. So 0.1 kilogram times the specific heat capacity of water, which is 4180 joules per kilogram Celsius. And then we just need to use a calculator for this. So the sig figs here, we have 3 sig figs here, 3 sig figs here. So the answer should have 3 sig figs. Because it's all multiplication division, we can just do this all in one go. We don't need to split it into separate steps or anything. So we have 0.5 times 1. Okay, so I already calculated the value here and I ended up with, let's see, I got 1.9 times, I guess I need a couple more decimals, 1.9138 times 10 to negative third degrees Celsius. Now, because I changed, and I do realize now that I did not provide the answers to these questions in the worksheet, so I'll try to update it. But since I changed the number of sig figs here, so initially this was just 100, I added the decimal there, so that would be 3 sig figs, which then means that we end up with 333. So we should have 1.91 times 10 to negative 3 as our final answer. Or if you want, you can write it out as, let's see, we need to add 3 spaces in front, so 0.00191 degrees Celsius. That would be just in decimal form. So that would be the answer for question number 5.